friends. Welcome back to Basic Advanced Math. Hope you're all doing well today. Today we are continuing Calc BC/Calc 2. They're equal. Today we're going to be going over trig integrals, going over the basics. We're going to be going over some of the functions. We're not actually going to be using the main 6 trig functions. Instead, we're using the inverse of the main 6 trig functions to make integrals easier when we come across a problem that we need to solve. So let's get started. First off, disclaimer, these are equal to each other. Oh, my bad. These are equal to each other. The sign of -1 equals the arcsin. A lot of stuff you see are going to say sign of -1. I write it as arcsin because I think arcsin is cooler. When it comes down to it, being cool is all that matters when you're doing math. So we're going to write as arcsin today. Right about now, you should have a formula sheet popping up on your screen. This formula sheet contains 6 main equations that we're going to be using to solve integrals. Not all 6 of these equations are that commonly used. The 3 most common are arcsine, arccosine, and arctangent. Regardless, all 6 of them are important to know. You might as well get those in your brain, memorize them, put it into the calculator. However you like to know them and however you're going to be able to use them, you need to know those, at least the top 3 there. So let's get straight into an example. We're going to go over how to use these trig integrals to solve problems that you previously would not be able to solve. And we're going to go straight into an example right now. So our example right here, we see is the integral of 1 over the square root of 1 minus 4x squared. This is where we got to use our skills that we picked up to try and make this equation right here fit one of the 6 that you just saw in the formula sheet. You will notice that this is vaguely similar, not even vaguely similar. It's very similar to the arcsine function that you saw, which is 1 over the square root of 1 minus x squared. It's very close. The integral, if this 4 wasn't here, would just be arcsine. However, it's not. Because we know the derivative of arcsine is 1 over the square root of 1 minus x squared, we can reverse the process and take the integral of this without the 4 and get arcsine. So that's how we know it. We flip it around, and that's how we're going to use these functions to our advantage and solve these integrals. So clearly we don't have it exactly in the formula that we want. It's slightly off. How we're going to get it in the formula that we want, we're going to use substitution to try and get it in the u squared form so that it fits the formula exactly one way or another. How are we going to do that? So we know that according to this equation, we need an x squared. How are we going to get an x squared? We are going to set this 4x squared equal to u squared. When we do integrals, we usually use u instead of x because x's are already in the equation. We need a different letter to use. So here we go. We're going to use a simple substitution. We're going to set u squared equals to 4x squared. Normally when we do substitution, we would set u equal to whatever we're substituting. However, due to this formula requiring x squared, we need u squared to be the substitution that we make. Now, as you can see, u squared equals 4x squared. We're going to simplify that into terms of u so that we can differentiate it. U equals 2x. Now we take the derivative of it to solve for du. Du equals 2 dx. The last step we have left is to solve for dx so that we can substitute this side back into the equation when we're all finished. So we're going to solve for it, and that's all it is. That's the end of our substitution. We now have everything we need to solve this entire integral. We've done all the calculations. Now we simply plug it back in. So let's plug it back in. Now, because we've already substituted 4x squared for u squared, instead of putting 4x squared here, we're going to plug in u squared. And then instead of plugging in dx up here, we're going to plug in du. However, we see there's an over 2 over here. So instead of putting it over here, where it messed up with the entire equation, it's a constant. So what we can actually do is just take it out of the entire integral, and we can put it back here. And bam, we've set up the integral that we're going to conduct. It's in the form that we needed. We took the 1/2 back here. Everything's almost done. All we have left is to take the actual integral of the equation that we have left. Let's solve it. We have this in the exact form as up here. X acts as u, u acts as x. It doesn't matter. Now we're going to integrate this and see what we come up with. We integrated it. The 1/2 stays out here because it's outside of the integral. The integral of this, due to that formula, is simply arcsine of x, or arcsine of u, because we substituted. The only thing we have left to do is resubstitute the x back in, and add the constant at the end of the equation. You cannot forget the constant. That will kill you every time if you don't embed it into your brain. That's the entire answer. That's all you need. You got to remember the plus C. You got to remember to substitute the U back in where it says U up here. Substitute that in. After that, you have to know at least the top 3 equations on the formula sheet. It would be nice to know all 6. However, the bottom 3 aren't as commonly used. You got to be able to manipulate this equation, whatever you're given, so be able to fit one of those 6. Integration skills require tons of manipulation skills. If you are able to somehow use all your skills that you've gotten through tons and tons of practice. Other than that, that's the integral of that equation. That's all I have for you today. This is Trig Integrals. Remember those 6, and I believe in you always.